So the easiest way to approach this question is to first test the divisibility rule for 9. So the divisibility rule for 9 is if you add all of the digits in the number, if it adds up to a multiple of 9, then you know that 9 goes into the number. So if we add up all of these digits, and a really quick way, it's not working. There we go. A really quick way to add up all of these digits is to pair up. 1 plus 9 is 10. 2 plus 8 is 10. 3 plus 7 is 10. 4 plus 6 is 10. And then we have a 5 in the middle. When we add that up, we get 45. 9 goes into 45, so we know that 9 will go into this number. If 9 goes into this number, the remainder is 0. So that would really be the fastest way to approach this question. This one here, most of you just added the numbers together. One thing that you can look at is trying to find sort of easy numbers to add together. For example, put the 2 with like 2048 or the 4 and the 16 together. That will make things a little bit faster. But the other thing that you can notice here, if you know anything about numbers, these are all what are called powers of 2. So 2 to the exponent of 1, which means 2 is equal to 2. 2 to the exponent of 2, which means 2 times 2 is equal to 4. 2 to the exponent of 3, which is 2 times 2 times 2, is equal to 8. This one is actually 2 to the exponent of 0, and that anything to the exponent of 0 is 1. So if you keep going through, these are all powers of 2. And what you're going to notice about powers of 2, so one thing you're going to notice about powers of 2, if I add powers, so for example, if I take the first 2 powers and I add 1 plus 2, I get 3. That's 1 less than 4. Or if I add 1 plus 2 plus 4, I get 7, which is 1 less than 8. If I add 1 plus 2 plus 4 plus 8, I get 15, which is 1 less than 16. So remember, a problem-solving strategy in math is to look for a pattern. There's always an easier way than just adding up all the numbers. So what I notice is when I add 2 powers or 3 powers or 4 powers, etc., and always the sum is always going to be 1 less than the next power. So if I look at this then, if I were to add all of these together, I need to first figure out what 2048 is. And so if I look at 2048, if I were to look at the next power of 2, the next power of 2, if I multiply that by 2, the next power of 2 would be 4096. So that means if I were to add all these together, the sum is going to be 1 less than that number, which is going to be 4095. So just kind of an interesting thing to look at using patterns. Certainly you can just add all the numbers, but a lot of you made some mistakes with that, and this is certainly a much faster way to get to the answer. So for the next question, we have a question about ages of brothers. So one way to approach the question is to just sort of start almost like guessing and checking, where you say, okay, let's say the youngest brother is 1. That means then the oldest brother needs to be 5 times that, and the middle brother is 3. So that could be 1, 3, and 5. Now that was 4 years ago. So that means now we need to add 4. So we're going to get 5. We're going to get 7, and we're going to get 9. So now the question is that middle brother twice the younger? The answer is no. So then we could try, what about if the younger brother was 2? Then we would get 3 times and 5 times. Again, let's add 4 to those numbers. And again, is the middle twice the youngest? The answer is no. So we could try 3. Again, we do times 3, we do times 5, we add 4, because now they're 4 years more. Is the middle twice? And the answer is no. We can keep going. We get 4, 12, and 20. We add 4. Whoops, I did that wrong. And now, is the middle twice the younger? The answer is yes. And so that means, I think the question that says today, how old is the oldest? The answer is 24. So that would be probably the simplest way for a lot of you to approach it. If you know anything about algebra, you can actually also approach this question using algebra. I'm not going to get into that here, but if you're interested in learning about that, come and see me, and I'm happy to go through that with you. So our next problem here gave a lot of you asked some good questions about this problem. It gave you some. So a couple of approaches that I saw, some of you sort of thought about, I could put, oh man, the pen's not working. I'm just going to pause for a second, see if I can get it to work. Okay, sorry about that. Pen's working again. So a lot of you sort of thought about it in this kind of way where the tiles would get lined up. I guess I should have used two colors, but there's one tile. So the tiles would line up in that kind of fashion. The best way to start is to think if the rectangle was 7 by 5, so picture 7 and 5, the area of that rectangle, base times height, is going to be 35. The area of each of these is 3. So the area of the rectangle is 35. The area of each one is 3. So how many times does 3 go into 35? So 3 goes into 35 11 times, and you have a remainder of 2. So that means your answer cannot be bigger than 2. There is absolutely no way that your answer is bigger than 2. There's absolutely no way that your answer can be bigger than 11. So now the question is, could the answer actually be 11? And to do that, you have to think about splitting this up. So when I make a rectangle like this, it's 2 by 3. So you can think about having your 3 here and your 2 here, and another 2 by 3. So here's a 2 by 3, and here's a 2 by 3. And then you can think of having it, turning it the other way into what would be a 3 by 2. So then your 3 by 2 could go here, and you could go here. And then you can see that I haven't drawn this well, but if this was 2 and this was 2, that's 4. I've got 3 left over. So this could actually be right here, one that went 2 by 3. And then you're basically just kind of filling in the little pieces, and you're going to end up with an L shape in here and another L shape kind of here. You're going to have 2 little squares right there and right there that are left over. And so, in fact, yes, you can put 11 of these in with 2 empty squares. And so the answer to this one is 11. So this one also stumped quite a few of you. So what you have to realize is if Adam can paint the classroom in 6 hours, that means in 1 hour, and it's not working again, there, 1 hour, 1 hour, he can paint 1/6 of the classroom. And then if Ben can paint the classroom in 12 hours, this is for Adam, Ben in 1 hour can paint 1/12 of the classroom. So if we combined forces, if Ben and Adam work together, 1/6 plus 1/12, we need to get a common denominator, and that might be new to some of you. When common denominator means to make the bottom or the denominator of the fraction the same number. Whatever you do to the bottom, you have to do to the top or the numerator. And I get 3/12 of the classroom, or that simplifies to 1/4. So together in 1 hour, they can do 1/4 of the classroom. So then how long do you think it would take them to do the entire classroom? If that's 1 hour is 1/4, then 2 hours would be 2/4, and 3 hours would be 3/4, and 4 hours would be 4/4, which is the entire classroom. So the answer to that, together, it will take them 4 hours to paint the classroom. If you have any questions about any of these, please come and see me. I'd be happy to go over them with you.